Today I'm going to be showing you about the distributive property, also known as just distributing, and it's something that's really important that we do use a lot in algebra, that you'll use in your higher math classes that you're going to take. So I think it's going to be good for us to go over it and to review it for some people maybe, but what I've done here is I've drawn two boxes, a box for addition and a box for subtraction, because those are the two main operations that we see when we are going to be distributing something. So doesn't matter if it's addition or subtraction, though the process for it is still the same, but I just wanted to show you visually what a problem might look like if it has an addition sign in it, if it has a subtraction sign in it. Okay, so let's just start here with the addition box here on the left, and when we want to distribute something, when they're calling you to distribute something, it looks kind of like this kind of pattern here. So where you have some number and it's directly next to a parenthesis, okay? And when I said directly, it doesn't look like this. Okay, see how in this one that I just hand wrote here, there's a plus in there, or maybe it might look something like this. But there's a plus or there's a minus separating the letter in the parenthesis. That is not telling you to distribute the A inside, okay? That's a different situation that I'll go over later on, but in this case, there's no plus or minus separating the letter in the parentheses, so we know we're just supposed to be distributing the A, okay? And when we distribute the A, it looks like this. We're bringing the A and putting it with the B, multiplying it to the B. We're going to bring the A here and multiply it to the C, and when you're done, it ends up looking like this, okay? A times B, and then the plus sign is just this plus that was here, plus A times C, okay? Sometimes they might have it on the other end, so maybe the number might be on the other end, but again, there's no plus or no minus separating the parentheses and the letter, so that's telling me we're just going to work this way then. Go here, A times B, A times C, okay? And it yields the same thing here. Okay, same thing for subtraction, it's just that we're just going to end up having a subtraction, a minus sign in between them, okay? Still A times B, still A times C, but there's a minus sign in between here. Same idea here. B times A, C times A, and because there's a minus in here, this becomes a minus, okay? And I've written this just to remind you that when you initially distribute, remember that this combination right here of putting them right next to each other with no plus or minus in between means that you're supposed to be multiplying the two together, okay? And once you've done that, once you've multiplied the two together, if it's possible, collect like terms, okay, so that you can simplify it and make the expression as simple as you possibly can. So that would be the second step to this. Okay, so first multiply after you distribute, or multiply while you're distributing, and then once everything is multiplied, try and combine it into the smallest and simplest expression you can make it. Okay, so let's look at some examples for this here, starting with number 1. So I have a 5x plus 2 with the 5 on the outside here. So again, what I'm doing is I'm going to be distributing it to the x and distributing it to the 2. And remember, when I distribute, it's just multiplying. So this is saying 5 times x. Since the x is a variable, I can't really combine it to make it anything more than just 5x. 5 times 2 is 10. Take this sign, which is plus, and I can't combine these because they're not like terms, okay? So remember, a like term has two properties. They have to have the same letter and same exponent. So that's a like term. In number 2, the 4 this time is on the back side of the parenthesis. We know it's a distribute problem because there's no plus or no minus separating the parenthesis and the number. So it's a distribute. I'm just distributing backwards, so the 4 is going to distribute into the 6y and to the 7. Remember, That's just multiplying, so the 4 to 6y, I can multiply the 4 and the 6 together, and then the y just comes down. The 7 and the 4 can go together, multiply it, 28. Take this sign, the plus, and add it. Okay, and I can't combine this any further because I don't have any like terms. So remember again, like term has to have the same letter or letters if there's more than one letter in the expression or equation. Okay, so this one doesn't have a y, so it already doesn't qualify to be a like term, so that's as much as it can go. Okay, number 3, I have a problem because people get confused and they say, do I have to distribute this whole thing, 5n plus 7? No, you don't distribute the whole thing, 5n plus 7. All you distribute is the thing directly next to the parenthesis, which is the 7, and take that sign. So circle that sign too, just so that it helps you out, okay? So all this 5n is going to do is it's just going to drop down till the end to see if we have any like terms, okay? But again, you're going to take the thing directly next to the parenthesis and the sign that's right in front of it, and it distributes like this. So I have a positive 7n and a positive 7 times 3. So I end up with 7 times n is going to give me 7n. 7 times 3 is going to give me 21. But what do I know about this? This is the minus sign, so this time it's going to drop down here. And I end up with 5n plus 7n minus 21. Do I have any like terms here? Anything with the same letter? The 5n and the 7n both have the same letter, so I can combine those two because they also have the same exponent attached, right? They don't have a 2 or a 3, they both have just a little, we know that there's a little 1 here, I guess, okay? Mystery 1. So these two guys look exactly the same, so if I have 5 n's in my pocket and I want to put 7 more n's in there, I would have 12 n's total minus 21, and then I stop there because the 21, since it doesn't have an n, it's done. Okay, can be combined. Alright, so let's look at these and combining like terms one more time. So I'm actually going to change this one up and step it up a little bit here, and I'm going to make this one instead 10a squared. Okay, so combining like terms, remember they have to have the same letters, which they all do, but they also have to have the same exponent. So these two guys look exactly the same, but the 10a doesn't because it has that squared there. So since it does, there's nothing else that has a squared in here, it just stays 10a squared. It cannot combine because it doesn't fit the criteria of having the same, has the same letter but not the same exponents. I'm trying to scroll back up here. Okay, same letter but not the same exponents. But these guys have 8a minus 2a. So think of it like this, if that confuses you a little bit. I have a box and I have 8 a's in there. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I have 8 a's in there, and then I want to take away 2 of those a's. So I take away 2 of them. How many a's do I have left? I have 1, 2, 3, 4, 5, 6 a's. And that's it. Okay. Finished. Looking at number 5, let's collect terms in number 5. So I'll give you a couple of seconds to try and see how you do with number 5. Okay. Remember, check and make sure they have the same letters, but if they do, make sure they have the same exponents, then just simplify and collect them together. So you have negative 5r plus 10r. If you want, you can rearrange it as long as you keep the signs so that it looks like this. Positive 10r minus 5r, you can write it that way. You can think of it, you have 10 r's in your pocket. you want to take away 5 of them, how many r's are left? 5. Okay. So let's go ahead and look at just a few more practice problems and we'll be good for today. Okay, so number 6, the only difference is that I, instead of having 2 things in the parenthesis, I stuck 3 in there. But the same rules apply. You're just going to take this outside thing, and remember it's distribute because there's no what in between, no plus or minus. It's okay if there's a plus or minus on the left side, but there just can't be one separating the two. Okay, so I can go here, here, and here. Okay, so if I have a 5 times a 7y, I have a 35y. Okay, going to the second one, 5 times a negative 3z, I can do the 5 and the negative 3, will give me negative 15, and just drop down that z. 5 times a positive 4 is positive 20. Any like terms? Nope, because these are y and z, so they don't have the same letter, so we're done there. Okay, number 7, same thing, I just kind of just changed up the way it looks. So this is a 2-in-1 problem, 2 distributing problems in one. Okay. So here's the first one, and then here's the second one. Okay. And so, starting with this first half, I have a 4 times n, 4n, 4 times 7, 28. I have a plus sign here, so I'm just going to drop it down. Okay. 5 times n, or a positive 5n. Positive 5 times negative 3. Any like terms? So I have an n and an n here. I have 4 n's, I want to add 5 more. So I'm going to have 9 n's now. And I have a 28 and a negative 15. So a 28 minus 15 left there, which is going to give me plus 13. And that's it, okay? So again, the 28 and the 15 are also like terms because remember they don't have, even though they don't have the same necessarily a letter, they have a commonality that they do not have a letter. So they are also like terms, okay? Because they look pretty much the same. They just don't have a letter attached. So them both not having a letter or a variable attached qualifies them to be a like term. Let's go ahead and look at number 8. Okay, so again, it's another combo problem, 2 distributing problems in one. First half right here, second half right here. Go ahead and you guys work on this one, and then I will show you the answer, or check back in with the answer when you guys are done, and I'll do all the work too for you. Another thing I want to make sure of is that you just understand that this 10 here is coming from a like term between the 24 minus 14. I realized that I forgot to show you guys how to do something if they give you a fraction. So I've given you a 12 times 2 times r over 5. So you remember from your packet to go ahead and solve that 2 times r over 5 out. And so to make that 2 a fraction, just remember to throw a 1 underneath and work right across. 2 times r is 2r. 1 times 5 is 5, so 2 times r over 5 in this big circle there is the same thing as 2r over 5. To combine them, drop that 12 down, and you just repeat. So 12 times 2r over 5. Remember to make that 12 also a fraction, maybe to make it easier, so you can just multiply straight across. You get 12 over 1. So just going straight across, 12 times 2r is 24r, and 1 times 5 is 5. So remember, work on this first inside and simplify to get it to be one fraction, not a big number attached to a fraction. Okay, so 2r over 5. And then if you have just a regular number, here, and you want to turn it into a fraction, just put a 1, put it over 1 in the denominator.